Formulation perspective, we basically leverage the use of water-based. We currently have two validated chemistries, LFP and NMC, and or NCM, and we evaluated several chemistries, but makes no sense for now to implement any of those chemistries because we, I would further discuss, we don't have the good customer understanding of what the applications are, so it doesn't make much sense to invest into those. But the whole point here is that we need to develop a manufacturing system that is chemistry agnostic. Yes, sir?
Do you think it's a better role for somebody in your position who's actually making these products and sort of understands their capabilities to be the person who advocates for particular applications, like, you know, in other markets? Because let's say you're a wind developer. Are you necessarily going to understand what your company might be able to offer them as well as you can? In other words, who really should be driving the innovation process or the communication process? Is it somebody in your position, or is it somebody in the consumer end?
I think that is or at least we take it as a collaboration. So we know that the people in Hawaii that runs the hand mills, they cannot receive the present because if the wind dies, they cannot start the generators fast enough. So it is an obvious need for energy. So the energy storage that Hawaii needs is not necessarily well defined. So the person that owns the windmill don't want to put any more money into the system because right now, whatever they make in the windmill, the government pays them. Okay? So to a certain point for them, put energy storage is a capital outlay that doesn't mean anything. But on the other side, once the government removes their money out, now it needs to make a little investment in the energy storage. But that is not the amount of energy necessary to optimize the windmill operation is not well defined. So from an international battery perspective, we needed to make great cells that can be integrated into a 20-foot container that has a great efficiency and lasts long. Okay, but international batteries should not get involved in the business of designing the inverters or making the inverters, or because that part we would never be able to compete. And the amount of effort that it would take for international battery to develop a complete system just because it's lithium ion, right? I think it will fall short when the other guy comes in with a lead acid and provides the same thing. So I spend all my effort trying to develop a smart battery, okay? And then when I end up in the end, I didn't achieve nothing, okay, that is superior to the guy that came back with a dumb battery, right? And instead, we should, the people those companies or those organizations that work in the development of manufacturing, they should stay away from the inverters and just those parts that are related to manufacturing of the batteries, right? And that's what we basically work on, is the validation of designs that satisfy application-specific efforts, right? The person in a car don't necessarily have to worry so much about how the bus bar is designed as the person, for example, that operates 1 megawatt system, okay? And the design of the cell is completely different, right? I mean, the design of a module for I've been heard, and this is actually public, that a lot of the car companies are somehow pushing this whole business that a battery can be used in a car for 5 or 6 years and then taken off and put it in some container and become part of grid regulation. Okay, it may make sense on paper. Okay, I want to see a Southern California Edison buying used product to put on their substations. That's going to be an interesting concept. But on the other side, if we make a battery that lasts us 5 years on a car and then can be used another 5 years on the system on the grid regulation, then why doesn't that battery last 10 years on the car? Right? I mean, okay, so you see, we're spending a whole bunch of time trying to figure out how to make these modules. I don't even know what to call it, but in the end, our manufacturing system, it doesn't come to the United States because we don't have the 300 people that manually roll these things and insert while breathing NFP. That's why we don't do it in the United States. You know, we don't do these things in the United States because the technology of making these cells really couldn't be transferred to the United States. It doesn't matter how much money we throw at it. It really doesn't matter how much money we throw at the manufacturing in the United States. We cannot pick up the stuff from China, bring it to the United States, and do the stuff the way they do it in China. Unless we just throw away the whole thing, or the OSHA and the EPA or whatever, and they say, okay, for you guys, because we give you so much money, we allow you to do whatever you want. I mean, if that's the reality, right? The other part is that because this manufacturing is somewhat new, there are a lot of process parameters in the manufacturing that we don't clearly understand. And we spend quite a bit of time in trying to understand these parameters, how to make it. For example, I'll give you a little position that I have. One of the main problems, whatever we make, we coat carbon, basically. That's the whole business. And we know that the pH of the wet liquid, when we put it on top of the foil, the substrate, as we would like to call it, has a huge implication in how the product comes out. But we don't have a test methodology that is able to somehow differentiate good from bad. We don't even know what good and bad is to a certain extent, right? Because when we put a cell, we say, okay, this cell will last 15 years. We do accelerated life cycle test, and we agree that based on that test, this cell should last 15 years. But we cannot, this accelerated life cycle test has the name accelerator, but it lasts us 4 months. Right? So from the point of time that we develop to the point of time that we have some fingerprint on what this thing will do is way too long. And we need to have a methodology that somehow is able to speed up the implementation of these manufacturing systems. The other part here is that we need to create a manufacturing process that can be deployed. So there is a huge amount of time and effort in making sure that we create design history files and that we develop the manufacturing in a way that we can deploy this. Look, 3M is a world leader in PSA tapes. It's not because the chemistry of the PSA is great. Almost any chemist can do that stuff. The whole deal is that 3M has the best integrated manufacturing system for PSAs anywhere in the world. They can take a factory, they can put a factory in downtown San Francisco, and nobody will know they were there. That is not the same thing with lithium iron phosphate. Currently, if somebody puts a lithium iron phosphate anywhere, a factory for lithium iron phosphate, you will know it. Okay? And that's the main difficulties that we actually dealing with in the United States. If we go, yes, sir.
Are you using essentially batch process or continuous flow processes to manufacture these slurries?
No, the slurry is made in a batch process.
How big is the batch?
Right now we're making 200 liters at a time.
200 liters?
Yes.
Isn't that, I mean, no disrespect, but that's really tiny.
That's tiny. You just have a lot of batches going.
Oh, so you have multiple, you have parallel path.
Yeah, the factory never stops.
But I mean, in other words, so you're making, how many lines do you have at 200 liters each?
Right now we have 4 lines.
I see. Okay, so it's basically 800 liters per batch per.
No, it's 200 liters per batch, because you have, you see, here is the whole deal is that you have to have some sort of accountability for everything you do. At this point, basically, we have full traceability, just like in a medical company. The stuff comes in, the products come in, they go to an inspection, they get analyzed, they get lot number attached to it, the product gets made, the product gets coated, the electrodes get stamped and whatnot, they get stacked, cells get filled, get formed, and a cell has all the data attributed to it. So today, we would like to improve it, but today we have a validated process, and we wanted to integrate a little bit more of the process down before we go bigger.
So do you anticipate that you're going to be able to bypass much of that process at some future time, or is that just going to be the de-rigger of all time?
We anticipate that we will bypass a lot of the steps by vertical integration. In other words, if I make my own iron phosphate, okay, I don't need to test the bag, right? But today, because I don't make the iron phosphate and I don't have a clue, okay, how was it made? And that's not necessarily true, but for the most part, it is true in a lot of the areas, especially if you buy products from China, right? If you buy the raw material from China, it's very difficult to get a certificate of analysis that reflects what is in the bag, right? So you have to test almost everything. Because on the other side is the school bus with the kids, right? You know, it's a brilliant YouTube advertising for your company, right? So back to the